Now, before I get into the lectures, and possibly we will try to make these lectures more interactive so that rather than me just talking about things, we can kind of understand things. So I have a couple of questions here, which I would like you, all of you, to kind of answer. This will help me to understand what should have contained and what the label of the talk I should be having. So if you can go to a site called menti.com, you can use it laptop, mobile, whatever, as long as you have internet. If you go to a site called menti.com, it will ask you some code, user code. If you just put this code, which says 13292136 on the top, you see, you should be able to answer these questions. There are only 3 questions just to understand the what kind of audience I have, and it will help me to shape my talk. So very first question is, what is your current enrollment? Are you BTech students, master students, PhD students, postdocs, or any other? Right, so it seems to be we have a mix of people. So I will talk about some of the solutions, but I will also focus on problems, understanding what kind of challenges are there, and how to apply solution, and what kind of solution will be ideal in certain situations. Yeah, possibly the standard solution you can kind of Google and learn about that as well. So I'll talk about more customized solutions. The second questions I have is, do you have a background in security, or have you studied any security module? Not particularly with cyber security, any security module, information security, data security, network security, cryptography, if you've gone through. Okay, this is very surprising to see no. Okay. And the last questions I have is, so how do you rate your knowledge about cyber physical system security? And why are you interested in it? Have you okay. Right. Well, thank you everyone for these questions. I'll jump to the okay, so I'll jump to the first lecture now. In this particular lecture, I will be talking about holistic view rather than going deep into one particular scenario. We will try to understand how security has been evolved. What is cyber physical system? How it's different from cyber security in a general way. And how these physical systems are different from IT systems that we mostly know. Now, the very first thing we try to understand something what is called critical national infrastructure. We call it CNI in the UK. I think in India we call it National Critical Infrastructure, which is kind of similar thing. So I'm just giving the context of the UK government. So UK government has identified 13 sectors as critical national infrastructure, and kind of the criteria of understanding those terms is any facility, say any facilities, systems, sites, information, people, network, and process necessary for a country to function. So some of these sectors are sectors where we rely every day. Some of these sectors are those sectors which are not part of our routine or daily life, but they are critical for us. And some of those sectors we don't really use, but they are there for protection. Yeah, for example, nuclear sector, we don't really use it, but then it's there. Defense sector, it's there for us to protect us. These 13 sectors, you see chemicals, civil, nuclear, communications, defense, emergency services, energy, finance, food, government, health, space, transport, and water. And you see energy is one of the CNIs. Emergency services, they subcategorize, for example, police, ambulance, fire services, coast guards, and so on. Why we are talking about now critical national infrastructure, and what is the need of it? What is the sudden need? Why there's a noise saying we need to protect CNI? Any thoughts? Yes, yes, yes. It's a backbone of the country, but these systems are there since very long. They're not new systems. Yeah. When you say power grid has been there very long. Water treatment systems, all these systems are not new. But what is new is we are making our system more smarter. Yeah, we want to build a smart city. And what is the definition of smart cities? That we want to place devices that can automate things for us. They can make intelligent decisions. When you walk in, door should be open, light should be switched on, and blah, blah. Yeah? At the same time, they should work efficiently. At the same time, they should be optimized. Once you walked out, everything's shut down, and so on. So this is one of the very simple examples how the smart systems work. Now, in order to facilitate that, obviously, you will put some devices which are talking to each other, collecting some data, sending that data somewhere else to process it, so that certain decisions could be made. And now we are not talking about infrastructure of an organization. We are talking about scalable infrastructure, country-wide infrastructure. Yeah, power system is country-wide. You got electricity from power grids. What if a grid is down? We don't have electricity. So maybe last 10 years back, not having electricity is not a big deal for a few days, even, or for a week. You manage things. We had a system in place. But now we have more reliability on smart systems. We have mobile phones, we have electric vehicles. Yeah, there's a lot more dependency on those systems. Now we can't really live our life without these systems, right? You always look for charger, my battery is draining, whether it's a laptop, mobile, whatever. And let's say there's an attack that can down the grid and you don't have electricity for a month. How will you, especially in winters, where you need hot water, for example. Yeah. In India, it's still manageable, but you can think of countries where the temperatures are really in -10, -20, and you don't have electricity. Because those countries have heating, all over the places, like we have air conditioning. So if you're sitting in -20 without heating, without hot water, you can't survive for a month. Yeah? So that will be a really disaster for that country if something like this happens. It's not just about the reputation, it's about you have to suffer with that harm. Therefore, it's really, really important to understand what is your infrastructure, because it's very different from country to country. Some country might have one grid, some country might have multiple grids. Some countries have really large populations, really high demand, some countries have low demand, and so on. So these, you have to understand system, you have to understand what kind of risk there. So calculating risk is also different from country to country. And then what kind of solution you should come up with. that should help you in that context. And that's where we really need to understand what are the sectors, what are their challenges, why it's difficult to protect them. Yeah? As we are evolving with technology, so there's a saying by someone says, technology does not solve your life. It doesn't improve your life. Rather, it brings a lot of issues. We think this will help us, but it doesn't really help us. Yeah? Because technology can ease things, maybe one or two, but then it might bring several other things that we don't know until system has been exploited by someone else and so on. So we really need to understand technology, really need to understand these systems. What are the issues, challenges that we have as of now and we will have in the next 10 years. So when you talk about a solution, you don't develop a solution just to fix what are the issues as of now. You think like down the line, let's say next 10 years, whether the solution that I'm developing, will it work next 10 years? What will be the challenges in next 10 years? What will be the data look like? Yeah? What is the size of population look like? What is the size of infrastructure look like? What kind of new devices can come into there? What kind of technology can come in? For example, AI driven or whatever. So you need to take into consideration all those things and you develop solution for future. Not for current, not for past. You can't build solution just to think about what happened in the past. Obviously, you need to fix that, but you need to think what kind of problem that you will face in next 10 years. And you need to keep in mind when you are developing those solutions. Yeah? So these solutions should be sustainable and scalable at the same time. So if we talk about the threats to CNI, basically I can categorize into four broad categories. One is cyber threat, because we think now we have kind of deployed a lot more smart devices which are connected to internet, exchanging data, and so on. Yeah? So definitely we need to think about what kind of devices are there, what data they are collecting, and so on. Second is personnel, threats from the humans. And one of the key examples is insider threat. So in the US, there have been certain attacks, and we will talk about some of those as a part of tutorials. Some of the attacks were there where attacker cut down cables. Cables, internet cables, telephone lines, under the underground cables. That's it. An external person doesn't know all those things. They don't know where the cables are, what type of cables those, what connections are there. So definitely there's someone who have that understanding, that have some knowledge. Yeah? Maybe not directly the person who did this, but someone collected that information from the person who was ex-employee of that organization. And then the attacker used that knowledge to target XYZ. When they perform attack, they make sure communication is not there. It's cut down, so you can't report it, what's going on. You can't simply call police or people or talk to whether a control center or security officer or whatever. You won't be able to do anything when the system is under attack. That we see in the past. Physical attacks are not new. So you go temper a device, you see it sort of power tower, you unplug certain things. It's as easy as that. Yeah? You go to a remote area, you see big towers, you harm those towers. So again, those are kind of very different, but then more understanding about physical attack is how can you perform a physical attack that can destabilize the grid, interrupt your services, and so on. So attackers are not just thinking nowadays just to steal your data. And, that's a very small thing. They are more interested in how to perform an attack that can massively impact the system. Can I disrupt that service? Can I target this particular substation so it could down the grid for a month, and so on. So they are targeting a large scale attacks. And obviously there are environmental effects. If there's a flood, there's an earthquake, and so on, that possibly we can't control. So in this, we will be more focusing on cyber security and cyber attacks. If we look at this global critical infrastructure protection market, you see it's been growing 3.7%. It's been projected, kind of predicted 2023, but we see this kind of significantly, the growth is significantly larger than what's been reflected here. But we are expecting it will grow at least every 10 years, it will double the market and so on. So there's a lot of players in this, a lot of companies there who wants to contribute to the protection of CNI. Just to give you some context, I was looking into what is what kind of centers we have in India. So I don't know if you know, there's something called National Critical Information Infrastructure Protection Center. So they call it NCIIPC a couple of years back, and now they rename it. It's called, so they have called India.gov.in, where they, in Indian context, they have identified certain areas where they want to keep an eye what's going on in these sectors, what kind of challenges, requirements we have in the country. And from time to time, they develop documentations, guidelines, and so on and so forth. There's another center we have, Indian Cybercrime Coordination Center, I4C. This is particularly focusing on cybersecurity, where they have mechanism where you can report a crime through their portal. They have a threat analyst unit. There's a team who can manage cyber threats. They got forensic laboratories so that they can also do forensic analysis when the attack is happening, or post-attack analysis. It's a training center, research and innovation center, and so on. Then they have something called Indian Computer Emergency Response Team, CERT. Now, generally, CERT is a country-wide mission which will help you to create teams of different expertise. That's what we call it, emergency response team. Yeah? When something goes wrong, they have a plan in place, and they kind of try execute it. So here you can see they are kind of monitoring what sort of vulnerabilities coming up, CVEs. What is CVE? So it's called Common Vulnerability and Exposure. Whenever they are looking at software, there's a bug, there's a security loophole, we call it CVE. Yeah? So it's been recorded part of CVE and gives a number, and that describes if you are working on Windows Server XYZ, there's a possibility you can inject a malware in this way, for example. So they're monitoring all the CVEs that been discovered from time to time. They're also releasing certain kind of guidelines for citizens, for companies, and so on. They have something called Cyber Swachhata Kendra, where companies, international partners can also collaborate in the mission. So they can kind of strengthen country-wide mission. And they are more particularly focused on phishing activities, because there's a lot of fraud going around with the phishing email or messages. And they got another portal called National Cybercrime Reporting Portal, where you can report again 1930. That's what we hear when you call someone. Yeah, that's advertisement. They created citizen manual, cyber safety tips, cyber awareness, and they release certain digests for people to be more aware. I'm not sure if you have looked at all those documents. So it's good to have this understanding, and possibly we need to build our habit to just explore what's going on there. So you're more up to date, what are the recent threats, what are the recent frauds, and so on. And that's where, based on the kind of incident they report, they release those documents, they prepare what kind of recommendation I need to come up with in order to help citizens with some kind of solution. So they release those reports, will help us to understand. Again, these are not technical, I guess, more kind of citizens. Now, what we have in the UK is called NCSC, which is a national cybersecurity center set up by federal government. They have an office in London, where obviously they do all kind of things that I'm talking about here, but they are more particularly on mission in a way. They don't just teach cybersecurity on higher educational level, but they want to introduce, and they have introduced cybersecurity at school level, colleges level, and so on. So we have a program called Cyber First. So Cyber First is a program for school girls between 10 to 16, some age restrictions. And the whole purpose is we bring those students, we organize as a university, we organize those fest, Cyber First, where we call those girls at our campus. We give them an understanding what sort of infrastructure we have. We play with some cyber hacks in forms of games and so on. Yeah? But we also go sometimes to school level, 4th standard, 3rd standard, 2nd standards, and then talk them cybersecurity, but not in technical way, but more on simplistic way, just to give them more awareness, what to do, what not to do, if they have access to the, for example, mobile phone, how you help them guiding what to do, what not to do. So they are kind of creating this as a habit, infusing it in their culture, so that when you grow up from 2nd standard onwards up to college level, you get a sense what is cybersecurity. You understand what are the hacks, what is phishing, what is spamming, and so on. So it's not like you have to go in technical to understand things, but just kind of basic understanding, awareness will help you. When you get to hear from time to time people, you visit certain universities, campuses, you get a lot of sense. You play with, in terms of games. Through games you learn a lot, because for kids, you can't really teach them kind of lectures. You can engage them in the form of games. So you create certain games which are cyber related, gives you awareness, understanding what to do, what not to do. So, but apart from that, we have something called Industry 100. So UK government also pushing cybersecurity, attracting small businesses who work on cybersecurity, can lead cybersecurity aspects. So they have a group of 100 companies which are kind of focusing more on cybersecurity. UK government also released some cyber assessment framework. If you are a company, how can you assess your cybersecurity understanding of the organization? So they have certain standard framework, anyone can use free of cost, and so on. And of course, cybersecurity is a very big thing, because the government is promoting it very seriously, and in fact, UK is one of the leading countries in terms of cybersecurity. They also offer something called NCSC certifications. So as a university, we have, we call BSc and MSc there. So we have BSc in cybersecurity and MSc in cybersecurity. We have both courses certified by NCSC. So when they certify, they say whether it's a gold, it's a silver. And one of the requirements for gold, fortunately we have gold, one of the requirements for gold is you don't just teach cybersecurity to the students of cybersecurity. You have to introduce cybersecurity at the university level. Yeah? Even in a simplistic way, we have people from business, we have people from other engineering and other department. They have some fusion of cybersecurity in their curriculum, so that everyone can understand basic cybersecurity aspects. Obviously, if you need more technical detail, then there are people who are experts who are learning cybersecurity in more details. Yeah? So that's how they are promoting cybersecurity at all level. And obviously, they have a lot more kind of guidelines. They release, similar to this, they release guidelines on phishing, how to strengthen your password, what is zero-day attack, and so on. So you can easily. Now, when I'm talking about phishing, I just wanted to highlight some of the work that we are doing currently. Some of the works are funded from defense and government, so I can't really reflect in terms of solutions and so on, but I'll give you a sense what we are working on some of the projects. So one of the projects is social engineering phishing email detections. So we got to see a lot more phishing emails, how you detect which of the email is phishing, how you can kind of create models, machine learning models that can help you doing so. And one of the trick that we use, solution is used with something called feature hashing. I don't know if you heard about it. So we use hashing technique to this. What is hashing? Right. So it's rather than looking at the index, I have a certain feature from data set coming from different companies, or so you're collecting data set first of all. So rather than looking at the index, because when you match it, whether this email is phishing based on certain characteristics, it computes the hash value and then computing hash where it finds, rather than you have indices where you can store everything in your database and then you are matching those indices. So it's a kind of a bit efficient method. We are also using NLP to reflecting how the decisions are being made, how you can contextualize this in the kind of human aspect. So obviously the standard process, you got a data collection. Once you collect data, maybe the data is not ready to process. Yeah, because you are detecting spam. So how you define spamming, right? Sometimes you have to also correct the words. So you got sentences, you break down it, extract the tokens, words. Yeah, within the words, you have to sometimes make it correct in a sense. For example, caring. So you have to convert caring to care, yeah, and so on. And then similar. And then you have certain keywords, or maybe you can use data set of phishing email. Yeah. So those keywords, URL, whatever is the process, you match those things from your data sets ideally. Now, how well you can optimize this, what should be, how well this process can work on the scalable system is kind of depend on the algorithms and the machine learning. So we did certain tests. For example, you look at the holistic process. We got data. You apply NLP to filter it. You apply feature extraction. You train. You divide your data set in training and testing, and so on. And then you kind of train and test it. Yeah, what does the accuracy look like? So we did certain experiments, like once you do the holistic things, then you try to see if you can optimize some of the intermediate processes. Yeah. So for example, you look at this training, you try kind of play with around how you divide training and testing samples, and what kind of samples would be good enough to carry. Whether your database is balanced or imbalance, yeah, whether it's undersampling, oversampling, and so on. I'm not going into detail, but I believe my colleague from Jammu has covered kind of machine learning in a good detail, so I'm not going into detail. But then you also look for what should be the volume of your data set. You also look at what sort of features you will consider. So let's say if you get 50 features, whether you want to go with all 50, you want to filter those features, play around this to see which combination of the features will optimize your results. Yeah? So you all play around this and come to some solutions. So we kind of did something, and we come up with some solutions. Again, this work is still going, so I'm just not going to focus much. But then it seems to me that this technique is better in terms of, so it's a storage vector size reduction is only 8% of the original size, and then twice as fast as the traditional method. So it seems to be this is really promising method, but we still need to kind of play around this. Second could be example of understanding phishing websites. As I said, traditionally it was okay. So what is a phishing website? Generally what was happening earlier, you have a website, we understand whether it's a phishing or not. Most of the time people look for HTTPS. Yeah, what is HTTPS? It's a secure hypertext transfer protocol. What is secure here? How does it secure? So mainly it says whatever transmission or data exchange taking place from this website connecting to a server or whatever, it's using something called SSL. Yeah, secure socket layer or transport layer security. So your data is already encrypted when it leaves and so on. That's why it's considered safe. But now what if someone comes with a very similar website with a kind of fake content. Content are also same. I have come across with this. Actually, one of my friends dropped me an email saying, I got an offer from Dubai. He didn't even apply. And then he sent me this saying, this is the web link you can go through. Because generally we don't remember the web link. We don't remember the website address. So when I click on this, I find all the pages are exactly same as the legitimate website. Exactly same. What is different? Contact details. And they were saying, oh, we can manage your recommendation, everything. You just pay some amount so that we can reserve it for you. They were asking for 50,000, something. So this is a kind of tricky game. And it was not as difficult in the past because when you look at certain things, you can kind of crack it. Now it's more organized. It's really, really hard for you to understand what's going on. So some of the examples could be, obviously, URL shortening. Nowadays, there are websites which can shorten your URL. Yeah? Rather than posting the whole URL, if you pass your actual URL, they will give you a shorter URL. And generally what we post, whether social media or whatever. Now, how do you get a sense that this is the correct address, even if you know the address of a website? It's kind of impossible to understand without clicking whether this is a legitimate site or not. Yeah? So things were made and being made in a good way, but people are misusing it. The whole point was rather than people to remember the whole address, it's good to have smaller address so it's easy to, yeah? Yeah. Pop-up windows, we all know. Sometimes you are forced to enable those windows in order to complete certain things, but then there are websites which will by default enabled. There are URL which redirect you. Once you go to a site, press enter, it will automatically redirect you to another website. And you start believing that this is the same website that you're going to. There are certain symbols people are using. So sometimes really, some websites really use long URLs. Yeah? And in that they have a space, underscore, @ blah, blah, blah. So there are cases where it says dashes in URL can be used to mimic a domain. So for example, if you look at here, which I can't show here, https fake-book.com. You might say this is Facebook, you just go there. And actually all the pages are same. There's a login page where you log in, put your user ID and password. It will say incorrect. But the actual website has captured your detail. And it will go to the actual website, put your user ID password, and change the password. And hack your system. Yeah? Similarly, Facebook.com and then @ some other site. So what it does is, it will go to Facebook.com but then redirect to the other website actually, automatically, without knowing you. So that, these tweaks things which generally people don't recognize because we are not trained that this is what is going on. That's where it's really important to have these kind of awareness. This is not really technical, but then sometimes it's impossible or very difficult to understand whether you are a legitimate or a fake website. Now, one company came with one of the solutions. They said, on our website we will put an image. If you see that image, you consider you are on a secure website, which may not work. Because then as an attacker, I can also copy that image and put on my website, isn't it? So what they come up with saying, when you log in, what you do is, I will show you a group of images, and you have to pick 3 images with a certain sequence. So next time when you go, you'll get to see 8 images in a frame. You have to click what were the 3 images you selected at the time of registration, and what were their sequence. As long as you are correctly doing those with your user ID and detail, then you'll be logged in. Because the fake website may have some images, but then it doesn't work the sequence. Sequence is the thing you only know of the database. Yeah? So those kind of solution might work here. And then what is favicon? Yeah, so when you say google.com, in front of the address bar, there's an icon. Most of the companies have started doing this. It's called favicon. This was introduced claiming that this will kind of identify that this is the actual legitimate website, but kind of may not work. Attacker can also use the same, copy it on their website, and so on. And obviously, there's a web page's content. There's a lot more malicious script, URLs, and dodgy things. And they intentionally ask you to claim it, to click it, and so on. So again, you can do the similar work in a way, train your model that can efficiently detect. But building those models, you need to understand the complexity of the attack scenario. You can't just simply say and pick one data set that's having malicious URL links. And you say if your link is one of those, it's a phishing, otherwise not. So now understanding problem itself become complex. You have to understand what are the different ways attackers are using to create phishing content. Yeah? You have to feed this into your system, obviously, in order to process your system to understand all these things. And there only you can develop those kind of effective solutions against these ongoing threats. We are also doing some work around federated learning. What is federated learning and why we need it? Yeah. Spoofing and phishing are two different things. So phishing is what? Somebody is phishing you. Phishing is like, I don't know if you've seen this meme or the video where there's a mother who is feeding her child. And when the child opens, so he's showing the chocolate, and as soon as that girl's open the mouth, put the spoon. That's a phishing. Yeah? You're showing something, but actually it is something else. So that's what phishing about. Phishing email, phishing messages, and so on. Redirect you with something else, which is malicious. Spoofing is something you are fabricating something. I can spoof a message or email that seems to be coming from legitimate source. So let's say if the email is, say, director@nith or .ac.in. I can fabricate an email and send the message with the same email. That's called spoofing. So there are tools that can help you to fabricate, to create message from those emails, which are kind of seems to be legitimate. And you will start believing that this is the actual email because it's coming from this address. But it's not been sent by the actual person. Yeah? So what kind of solution we can have for that? It can happen, but for website, it's still difficult because somehow your website hosting somewhere, having a domain name, so maybe those kind of information, and you have an IP address. Again, you can also do IP spoofing, but kind of a group of characteristics can help you identify things. But in case of email, for example, if it is coming from the same address, which say director@nits.ac.in, how will you get to know that this is a fabricate, this is a fake email, not the actual email? Yeah, so we'll do one of the exercise in tutorial to understand that. Something is called email authentication, we'll do that. Okay, so what is federated learning? Yeah, so as I said, one of the problem with traditional learning is you need data to train. You need to have actual access to the data. Yeah. Now there are certain applications and sectors, for example, healthcare, finance, where companies don't want to reveal their data. So what they will, and of course, for example, I'm talking about 5G here. how is this 5G different from other generations? One of the key differences is 5G network allows multi-vendor thing. So it's a radio access network. It's an open network that wirelessly connect. Yeah, so how does your mobile system work? When you turn on your mobile, what it looks for? Nearest tower. So we have certain control channels. So those channels get access. They start scanning, and then try to see which is the nearest tower it can connect to. If you have a Vodafone SIM, it try to connect to Vodafone SIM, and so on and so forth. Yeah. And in background, it does authentication, which you don't kind of, maybe as a user we don't realize, but it does kind of authentication to see it's connected to the right network. And that's where you get to see if the Vodafone and Air tower next to each other, how would your system mobile get to know which tower it has to connect based on the authentication where it can connect. Yeah. So similarly, again, in 2G, 3G, we were having kind of very less vendors. And most of these systems were vendor specific. There are very few companies. Now it's kind of in 5G, the way it's been structured, there are a lot of involvement in different vendors with different devices, different level of devices. So you are talking about different types of devices. Now one of the difficulty with this is different manufacturers and vendors, these devices run different protocols. They collect different data in a different format and so on. So it's not straightforward to connect all those devices and you can collect your data. It's not going to work. Sometimes those devices also have certain constraints and so on and so forth. Yeah. So in a simplistic way, if I say the vendors do not want to send their data, what they're collecting, and as a company or utility owner, whatever you call, we want to do some computations over it. That's where federated learning comes, where you can, as an organization, you can train your model and then share your model with the centralized body. So all the companies will train their whole model with the data, send the model, not the data. And then that centralized body will compute the global model. And that's how they learn patterns, and the global model will adopt it. Yeah, what is the acceptance? For example, if I divide the country into northeast, west, and south, 4 zones, everybody has their own data, their own kind of system. You can train those local models and then create a centralized model that can accept all types of data, all types of protocols, and so on. Yeah, without sharing the actual data. So that is where federated learning comes in. And then people also start talking about cybersecurity aspect of the what if data is malicious, what if someone compromise your local model, what will happen, and so on and so forth. So again, as I said, we did some kind of work around this. We also introduced something else called differential privacy. What is that? Huh? Privacy technique, but what is differential? Anyway, we will be talking about in one of the, I guess I have one of the slides, but just to touch here. What is differential privacy? And what's the use of it? Have you heard this term? No? Okay, so differential privacy is something, sometimes it's been said, oh, if I need to share my data with someone, generally we say privacy should be protected, individual records should not be revealed. So maybe I can anonymize the data, I can remove person name, ID, whatever, and simply send the actual data. So that is something we call anonymous data. Someone can look at this and they will not be able to identify the individuals from looking at that data. Yeah. But sometimes we also don't want to send that actual data to the system. Yeah. For example, if I need to send 100 rupees to you, but I don't want anyone to know how many money I have sent you actually. I can give you 500 and then take you whatever remaining I want. That is the differential privacy. So rather than sending 100 rupees, I will introduce some noise to the data. So my data values, actual values will change. Yeah, and then you feed to the system. So the model don't learn the actual values, or it learns the pattern rather. And then the company that you are sharing your data don't hold your actual data. Yeah, so that is the purpose of having differential privacy. Okay. So as I said, we are also doing federated adversarial attacks on federated learning, considering what if there's an attack on your models where someone has manipulated, created your benign data to malicious, or the other way. If there's a malicious data, but then your models start believing this is the legitimate data. So those kind of attacks, yeah.
The differential privacy also there, and another techniques also there, like homo encryption. So shall we know in which aspect of?
I will be talking about homomorphing as well in one of the lectures, very briefly. Then we can talk more. So as I said, the whole point here, you got, sorry, let's say you have a machine learning model, you have your local model, you have a global model, everything is working fine. But now as an attacker, I compromise one of the local model, or maybe data. I manipulate data, and your system doesn't know, maybe in a way. Or I can, rather than data, I can target model. Yeah, because model is the thing you're sharing. I target the model, start believing this model that this pattern or this data is legitimate. The way I will tweak your model. Or the other way, if it is actual data, I will say it's malicious, or if it is malicious, I will say it's a benign data. And then you train your model and see how does it work. Does the kind of research we are doing try understand what should be the size of the data that we are infusing, malicious data infusing to the system, can actually make the difference, can actually start believing the system that the data coming through is actually legitimate. It doesn't understand that this is malicious data, and so on. Okay, so I thought maybe I should give some brief understanding. Let's talk about cyber physical, some more terms before we go for a quick break. So what is a cyber physical system? The three terms we see: cyber, physical, system. Cyber, we are talking about cyber security. Physical systems. Generally, physical system means it should have some part physically, some devices, some sensors, actuators, something. Yeah, we call them physical part, or maybe some devices, hardware setup, and so on. Sometimes when we say system, is not a simplistic system. When I say power system is really a complex system. This is a system of systems. There are several subsystems within the system. Yeah. Depending on how you see, I'll have a slide to reflect the whole power system. How does it look like? So it has units called, for example, generation unit. Different mechanisms how you generate power, electricity. Mechanism to transmit that power from generation unit to substations. Mechanism from substations to your home or to the industry, and so on. You see there's a certain voltage requirement for home, 220, 240 volt, 110 volt, and so on. Yeah, so there are certain processes involved that will lower the voltage, up the voltage, and so on. And this is one of the examples. But then you might have smart meter at home. Smart meter also kind of giving you electricity, collecting with the control center and other units. So they have several subsystems within the whole power grid. Similarly, transportation, whatever system you think, they all are systems of systems. They have several subsystems that are working together depending on what applications we are talking about. So cyber physical system, generally you see physical part as a sensors or devices that are used to control, collect data, and so on. And then you have communications. So let's say you got sensors. Sensors, what they do, you got actuators. Sensor collect data. Actuators help sending data through some mean of communication. Maybe Wi-Fi, maybe Zigbee, maybe 5G, depending on the application, how long the data should be sent. Yeah. And then once you collect your data, you run this data through the system, make certain decisions, and based on whatever your outcome, you decide what to do, what control action you need to take. So that's what is cyber physical system. Now there's another term called IoT. How do you see IoT? What is IoT? Internet of Things. What does it mean? Yeah. Now what we have is smart devices that are on the internet. Yeah, they're collecting data, sending data, and so on. So that's what we call Internet of Things. How Internet of Things different from cyber physical system? Are they same thing? Are they different things? If I say I have an IoT system versus cyber physical system, are they same things? Yeah. So I can say maybe IoT system is a part of cyber physical system. Because in IoT system, you have mechanics. So generally it's been saying there are 3 layers of IoT architecture. One is called perception layer, where you have sensors and actuators and so on. You have transmission layer, some mean of communication, and you have application layer feeding back. But then within the application layer, it doesn't elaborate more, where it lacks with physical system. In physical system, we pass the data that we collect to physical systems to understand what will happen to the system. Now I'm collecting a data from a sensors, and I'm modifying some of the data in that. What I want to pass that data on the physical system, whether I want to see whether it will work or not, how it will react, what kind of impact I see on the physical system, which generally you don't see in IoT system. So the difference, I would say, in terms of operational risk. So if I consider as an individual, I say I have a smart camera. Yeah, smart camera can automatically take pictures every 5 minutes, whatever, and send me on my email, let's say. Yeah. When you talk about individual device, it's not a system. Someone hack it, what will happen in worst case? They can get the picture. Yeah, that's it. Might be useful for creating attack scenarios, gathering information, but it doesn't have any direct impact on the system I have. Yeah. On the other hand, physical system, you are part of that system. Operator sitting at control center, if you hack them and they get into system, they will, whatever changes they will make, either they will inject malicious data, run certain malicious command, it will directly impact the physical system. Lines will be overloaded, underloaded, some devices may be burst if it is kind of overloaded and so on. So physical system have direct consequences. There's a train running, someone control their brakes. What will happen? So physical system have a lot more adverse consequence that could be life-threatening as well. There's a manufacturing plant. Someone controls big machines. That don't stop. Maybe it will harm people. So most of the physical systems have safety issues. We'll talk about those sometimes. So again, you got sensors. Sometimes now we are talking about digital analog systems. You got sensors, the sense data. You got analog to digital. If it is a analog sensors, in order to feed it, you have to use one converter from analog to digital. You pass this to your digital system, process whatever, make certain decisions, and then when you need to take action, you need to convert digital to analog, and then send your control command to control it. Yeah. Apart from cyber physical, there are also kind of some other systems we call it. Enterprise system. Now, I guess we will be talking about, I have a few slides. How does IT system is different from cyber physical systems? Now these kind of systems also called operational technology, OT. IT is called information technology. So information, I'll be talking about that in more detail. So enterprise system, basically we are talking about IT system, organizations, government offices, universities, companies, generally run on IT systems. What kind of infrastructure we need? Computers, laptops, internet. Yeah, you're sending data, collecting data, that's it, generally. Physical system, as I said, it's a physical process, physical services involved in that. Then you have social system, government social system, healthcare community, educational community, social media community, and so on. We're also collecting, sending a lot of data around it, which might influence people, not directly, maybe indirectly. What if capture someone photo, edit it, and post on, so those kind of societal issues are there. And then you got some biological system. What if so in the UK and whole European Union, healthcare data, finance data considered really sensitive data. Even the hospital cannot reveal that information. Somebody is suffering for disease X, cannot be revealed to anyone. If something like this happens, there's a huge penalty for company to pay. It's really huge. So these data are really sensitive. If you're working on those systems for security, machine learning, whatever, for whatever purpose, you need to be very careful what data you are using. Does this data that you're collecting violates any of those rules? Obviously, you have to protect the privacy, training your models, and revealing it. Yeah, so it also look at when someone release AI model, it should not also revealing patterns. Yeah, in a way that can help to identify individuals directly or indirectly. So these sectors are really kind of sensitive to work on, and you need labels of approvals to go around what data you are collecting. In the not about this data, but in general, European Union have a regulation, something called GDPR. I guess India has also come up with something similar. What is GDPR? It's a General Data Protection Act regulations, which says if you are a company and if you are collecting data of citizens living in European Union is 28 countries, I guess, group of 28 countries. You are responsible and liable to collect, to follow certain regulations. What data you can collect, how you will store their data, how you will delete their data, when will you delete their data, how long you will keep your data. So they have certain regulations that you need to tell the people who you are collecting their data. Yeah. So many of the companies don't bother it. For example, Make My Trip, all those, Yatra, something. If you open in the UK, it doesn't work. Because they don't want to have this hassle. And one of the difficulty if you're collecting data, let's say online payment system. You have a website where you are selling online products around the world. Of course, people from UK, any other country can buy that product. And you are asking them to pay through credit card. You're storing their credit card detail in a way. What if that data reveals? If that data reveals, you are liable to pay that fine. And the fine is it's a hefty fine. And in the UK, they also have something called ICO, Information Commissioner Office, something. If there's a data breach happen to your organization, you are liable to inform that there's a data breach. Because if they figure it out, that there was a data breach and you haven't reported it in the first place, there's a huge fine. There's also fine if there's a data breach, unless you are not following their guidelines. So if they say you have to put in place these kind of security control, and you have all done, despite of that, your data is compromised, you're okay, because you're following those things, and obviously there's always chances that someone can get in. But if you're not following the regulation, you've been attacked, you're liable to pay hefty fine, which is 4 million euros, something is really high, it's hefty fine. So the government is really serious about all those things. You cannot, it doesn't work like you can do these things and thinking you will bypass the system. You can't. And that's one of the things, that's where these systems are really working there, because rules are really tight, penalties are really high. You can't think of afford those penalties. You can't. Yeah, so working on those kind of systems, each of these systems bring their own challenges. Depending on where you are living, what kind of people, what kind of systems are around you. And that's where when you develop security solution, AI models, you need to take into consideration all those aspects. And then only you can customize your solutions that can handle and address the problem in that context. Yeah. What could be the example of cyber and physical attacks? So again, I'm saying physical is actuators, sensors, computing, so there could be information leakage, authentication failure, and deadline misses like you don't really able to do in time. So sometimes there are requirements that this data need to be sent from device A to B in milliseconds, for example. Yeah. And of course, in terms of cyber, mostly. So most of the people that, one of the misconception, I wouldn't say misconception, but most of the people who are from cyber security or computer science background, for them cyber attack is on communication. Yeah. When we say cyber attack, people think over the network, you do. That's attack, which is okay. But cyber physical system is not just about that. One of the things as an attacker, your intention is to harm the system. Physical system, not just to compromise data, not just compromise communication. If I'm able to compromise the system, manipulate data, and keeping value from 100 to 10,000, it doesn't harm system. My system is still okay. So as an attacker also decide and sort of design the attack in a way that can hamper the physical system. And that's where the impact of attack is really important to understand. I'll be talking about all those things in more detail in the next lectures. Do we want to have a break? Let's have a 5-minute break.